Okay, so yan. Resume recording. Okay, starting na. Good afternoon, everyone. Today, we're going to continue our lesson about electric fields and etc. Okay. So, tapos na tayo actually. So, wait, may tanong pala muna pala. Okay, so yan. So, question po, ninyo po ba na-complete po talaga yung solution, especially sa pag nag-integrate? Okay. So, pag may mga, kasi may mga trivial na integral, okay, mag-upload nga ako ng solution set kung paano yung sinasabi kong explanation. Ang nakalagay doon is yung mga bakit ito yung gagawin yung step instead of this step. Okay? Yung mga ganong explanation kung bakit ayun yung tinatahak yung paraan. So, dapat nakikita ko yun sa solutions nyo. Kasi kapag yung solutions nyo ay puro equations lang, what is this? What is happening? Di ba? Walang sense of direction. And yung physics, di ba? Kaya nga tayo nag-physics is to know why. Yung mga bagay-bagay. Why does that happen? Bakit ganun ito pinili? Bakit yun yung mas efficient? So, ganun na physics, di ba? Okay, so upload ko ito mamaya. Nagawa ko na siya. Dito sa likod ko yung solutions nung sa prob set. So every time nagpa-prob set kayo, gagawa ko din ng solution para fair, no? Nahirapan kayo, mahirapan din ako. Okay? Okay, so let's go. Let's continue. Today we're gonna calculate the divergence and curl of electric fields. Okay? From last time sa electrostatics natin, sa pag-calculate ng electric field, so far, tapos na tayo. Tapos ka na. Bale, with that equation, yung integral mo that builds up your electric field, that's it, no? Basically, you can do that for every problem. Pero, is it easy? Okay? Elijah, is it easy na mag-integrate ng ganun na problems?
Yung sa problem set ko, view sub lang po yung ginamit ko po. Tsaka onting trigonometric substitution.
Di ba ang hassle? Di ba ang ilang pages yung sinubmit mo?
4 po ata.
Di ba may 4 pages solution? Hassle. Kung ganun yung mga problem, every time na mas nagiging complex yung problem, edi may hirapan ka. Kuwari, rice cooker yung shape ng charges mo. Edi paano mo integrate yun? Di ba napaka-problematic? Alright, so, well, itong mga lesson na susunod is for us to have an easier way to solve for the electric field. Okay, so, divergence and curl of the electric field. So, bakit hindi natin sinama yung gradient? Yung gradient naman is, useful naman ng gradient. The gradient of the electric field tells you the slope of the electric field, kung gaano ka intense, gaano ka lalim dun sa at certain points in your electric field. So that gives the gradient of the electric field. So, okay, so mga slope lang yung gradient. However, the divergence and curl is not very intuitive for us. So let's try to solve for that. Okay? Okay. So simulan natin ngayon sa divergence ng E, ng electric field natin. Okay? So ito, this is, you know this, you've been working with this, itong integral natin. That is your, this is how you calculate usually for your electric field. And then we just recall this divergence. Ito yung sa mathematical preliminaries natin kung saan na-introduce natin itong Dirac delta. Okay? Okay, so far so good. Okay. Ayan. So wala namang ano dito, wala namang bago. So when we do this, let's try to calculate for the divergence of E. So that's del rigid E. This is just your usual constants. All space, all na lang guys. Pagod tayo. And then I have the del operator inside. Tapos yung R hat over R squared. Okay? And then we have your charge distribution of rho, R prime vector And then your integral bounds or integral infinitesimal value for the integral. Okay, so dito, so ibig sabihin volume. Tama? And then from this, we know that we can just plug in this value here. We obtain 1 over 4 pi epsilon naught. And then I'll just write this down. Delta. And then your rho r prime. So yung prime coordinates laging nasa ano, laging nasa charge mo. Okay? Okay. Okay. Okay, let's do this. I-expand natin ngayon si okay, no need para to expand si dito. Ang kailangan lang natin expand is yung itong value natin dito para magkaroon siya ng prime coordinate sa loob. Okay? So, 4 pi. And this is just your usual definition, which is r vector. So yung r vector mo is from origin to your point of interest. And then r prime. Then yung rho, r prime, theta. Oops, another space. Theta. Okay, no problem with that. And then we know that our integral bounds will occupy all space. So si theta dadaan siya kay r eventually. And that leaves us with 1 over 4 pi epsilon naught. Actually, pwede mo na cancel yung 4 pi. Ano tayo sulat ng sulat. You can cancel this one. I'm left with 1 over epsilon naught. And then yung rho ko magiging r vector. Tama? Kasi uusog si theta, papunta siya kay r. Tama? Si mga prime coordinates yung gagalaw. So ito ay 0 lang unless magtatapat silang dalawa, magiging 0 yung argument nito. Kapag naging 0 yung argument nito, saka lang magkakavalue itong integral natin. Okay? So to do that, i-adjust mo si r prime papunta kay r. And that's what happened. Kaya ito lang yung natira. Okay, so that is your divergence of your E. Now, that is not very useful. Anong mapapala natin dito? Hindi natin alam, di ba? It just tells you that you have your charge distribution, the charge distribution rho, which is R. Okay. And nothing else. But however, we can recall the divergence theorem, which is given by this. Okay, kinuha ko lang yan sa chapter 1 natin. And that gives me something with the divergence of, palitan natin si V ng E, the electric field. Okay, so when we have the divergence of E, and you have to integrate it with respect to some volume, not necessarily all space, basta volume lang. And we plug in things. We know that the divergence of E is easily this guy. So 1 over epsilon naught rho of R d tau and sum over V. And this tells us na lalabas lang tong constant, which is 1 over epsilon naught. And we know that pag pinartner natin, 0, di ba 0 ay volume charge distribution. So, pinartner mo siya sa integral ng volume. This just gives me the charge that is enclosed by the volume, which is, yan. So, yung constant mo, 1 over epsilon naught. And then yung charge na enclosed mo dun sa volume V mo. Okay, pag sinabi natin all space to, ang magiging kakalabasan niya is, so if the integral, if all space rho d tau. This gives me your Q, then Q total. Okay? Very intuitive, di ba? Okay. So we have this, okay, on the left-hand side ng divergence theorem. And then, this should be also equal to the right-hand side. Tama, kasi itong left-hand side mo, equal yan sa closed integral, closed surface integral ng E dot dA. So we have this guy, closed integral over a surface, and E dot dA will be your equal sa the above equation, Q enclosed over epsilon naught. Tama? Tama. So far, so good. So good. Okay. So we have this, we have this equation. Okay, what does that tells us? We now look for the definition of the electric flux. So itong electric flux, sinasabi lang niya kung ano yung amount of electric field that is passing through an area dA. Okay? So si flux ay itong Greek letter phi, capital Phi. And that is E, sub E. Okay, mahalaga yung sub E kasi mamaya sa magnetic fields natin, meron ding flux. Okay, so ito ay defined as a surface E dot dA. Okay. So this just basically tells you the number of electric field lines that is passing through an area dA. Okay. So when E, so lagyan natin if E is parallel to dA, what happens? Sabihin natin si E ay written as E, some arbitrary magnitude E, tapos yung kung anong direction niya, then we can write dA as A, capital A, yun din yung area niya, area vector niya, which is A hat. Or mata, mas magandang N hat na lang. Normal vector, N hat. Cute. Okay, so when we have E that is parallel with dA, okay, let's look at this figure, okay? Ayan, kung nagtapat yung yung E natin sa dA mo, ibig sabihin yung N hat mo, so E hat has to be parallel with N hat. And this tells me that if I get the dot product with them, it has to be the unity or 1. And the flux will simply be EA. Tama? Diba? Kasi pag dinot product mo na to, magiging magiging 1 lang yung E dotted with N, normal vector. And then, there you have it, diba? Simple. Now, if E is parallel or perpendicular, perpendicular with dA, how does this look like? So we have a surface, let's say something like this, and you have your N hat. And then if your field E points something like this, siyempre mas maganda ata kung ibang color. Ibahin natin yung color. Blue na lang. Okay, so if your field goes like this, then yung dot product nila will just be 0. And the flux has to be 0. Okay. Now, I'm referring to the vector. Medyo hindi siya intuitive, but you can always think of it as the surface. If E is perpendicular, if E is parallel to the surface. Okay? So E is parallel to the surface. What does that look like? Ito siya. E, ito yung surface mo. Parallel siya, di ba? Okay? Parallel to the surface or plane, whatever. Then, would be the same. Has to be 0. Then E is perpendicular to the surface. That has to give me the other one, which is E, A. Okay, makes sense. Nakakalito, di ba? Tandaan niyo mabuti. For this one, I'm referring to the vector, which is A yung n hat mo. Or kung saan nakatutok yung vector ng plane mo. Okay? The surface, that's a different thing. The surface is itong mismo drawing niya. So, the surface is always perpendicular to your area vector. Okay, tandaan yun. Nakakalito. Okay. Now, what happens is if we close the surface, ang lalabas is ito, di ba? Pag kinlose mo to, pag kinlose mo yan, lalabas lang itong solve natin kanina. And may special tayong tawag dyan, which is yung Gauss's law. Okay, so ayun yung definition ng Gauss's law. Okay, so anong ginawa ni Gauss? Bakit napunta na naman sa kanya? Ang daming ginagawa ni Gauss. Okay, so nung si Newton, nagsulat-sulat siya ng mga integral for your gravitational field. Okay, so nakita niya to, nakita ni Newton na parang ganito rin yung actually hindi nakita, ginawa ni Newton na ganito talaga yung equation. Similarly, ganito yung equation for your the gravitational acceleration or the gravitational force, okay? So similar sila na ganyan, i-integrate mo yung mga masses in business charges. And then nakita ni Gauss that you can just actually feel the strength of your the gravitational field outside an imaginary surface dA, and then you can know the total mass inside. So kinraid si Gauss dun sa problem na meron tayo kasi yung solution niya can easily be patterned into electric fields also. So yung mass, gagawin mo lang charge. Okay. So ayun. So ayun yung ambag ni Gauss. Smart kid. Okay. Okay. So ayan. Okay. Ngayon, syempre, ano ba silbi na itong Gauss's law sa atin? Yung Gauss's law, papadaliin niya buhay natin. Okay. Okay, let's do this. So find the field outside a uniformly charged solid sphere of radius r and total charge q. First thing to do, magagawa ka ng surface. Imagine ka ng surface such that E is perpendicular to surface everywhere. Okay? Okay? Perpendicular surface, ha? Okay? So for our uniformly charged solid sphere, so gawa tayo na bilog. Okay. And then we know that the electric field outside the sphere is just pointing radially outwards. Radially outwards for all direction, of course. Nasolve niyan sa prob set niyo. Tama, di ba? Okay. And then, if we can imagine a surface such that all the electric field is perpendicular to that imaginary surface, then we can easily solve the problem. So I can just imagine that my surface is just a sphere that's larger than my problem. So yung solid sphere natin. So gawa ko ng mas malaking imaginary surface, shell. Sorry, pangit ng drawing. Ayan. Imagine tayo ng surface that is bigger than your problem, which is yung solid sphere. So ito ay shell. And we can see that perpendicular lahat ng field mo. Okay? Dun sa surface na inimagine mo. Okay. Now, we do the left-hand side. Next, we do the left-hand. Oh. Okay, may saltik tong ano ko. Restart ako ng application. So that it works now. Okay, going back. Okay, let's go. Share lang ulit ako. Sorry for that. So yeah, going back. Okay, so going back, I have number 2 is to write down the left-hand side. Okay, so to write on the left-hand side, you just write E, your electric field that we want to know. Tapos, since alam mo yung imaginary surface mo is always perpendicular to your electric field, you can just write down that surface. And our surface will be 4 pi r squared. 4 pi r squared. Okay. 4 pi r squared. R squared. Now, small r, pansinin nyo na small r siya kasi arbitrary. I can extend that to infinity, but let's say for now, r lang siya, small r. And then lastly, you obtain the right-hand side, which is just the total charge that is enclosed. Now, pwede kong ilakihan yung r ko so that na-enclose lahat yung charge sa loob. Tama? Tama. So I can just do that. So yung total charge enclosed ko will be just Q. Okay? Total charge. Then this is also the enclosed charge. Enclosed charge. If R greater than R. Tama. Yung R, capital R will be yung radius ng sphere natin. Okay, and that's it. Solve na natin yung problem natin na pagsamahin mo na lang yung left-hand side and the right-hand side. So the left-hand side tells me that we have E, 4 pi r squared, then you have your Q, and epsilon naught, kasi naman may epsilon naught na extra dun. Natin, and may extra epsilon naught, so we have to write that down. Okay. And this is your answer. So problem set nyo. 1/4 of epsilon naught Q over R squared. Then we know that the electric field is just radial. This was your problem, di ba? Ito yung problem 2.8. Easy. Okay? Amazing. Okay, so galing, di ba? Hindi na ako nag-integrate. Okay, so let's try another example. Okay, let's do this. Number 1. Imagine the surface. So, ang problem natin will be a long cylinder. Drawing muna natin siya with long cylinder. Oops. Yan. Diba? Tapos, yan. Imagine niyo lang straight yan. Napakagaling ko mag-drawing, diba? Tapos, kuha tayo ng I'll take the rainbow one as my axis. Yan. Okay. Mahirap mag-drawing sa tablet. Okay. Now we have ayun yung long cylinder natin. So may charge density tayo na hindi uniform. Okay? So that is proportional to the axis, which is yung rho natin. Then yung Ks yung proportionality niya. So as you go along the S, lumaki yung S mo, lalaki rin yung charge mo. Okay? Okay, so this is a cylindrical problem. And then number 1, what would be my surface? Okay? So, si Alexandra, are you there?
Yes, sir.
Anong sa tingin mong valid na surface na gagamitin natin for this problem?
Sir, 2 pi r.
2 pi r. So anong shape ng surface natin?
Cylinder, sir.
Okay, cylinder. Dahil cylindrical yung problem natin. Gamitan din natin ng cylinder. Kasi, di ba, alam naman natin na ang usual na field mo will have to radiate outwards from your charge. Ito ay punong-puno ng charge. So, pansin mo na pag ganun yung electric field mo. Kasi, yung mga electric field lines natin, hindi pwede mag-intersect. So, pag ganun yung mga electric field. Okay. So, sipagin tayo. Pag ganyan yung... Isipin nyo na radially outward yun. Dahil cylindrical yung problem natin. Okay, so... Okay, thank you, Alexandria, for that answer. So, pwede tayong mag-imagine ng a larger surface, which is this guy. Okay. So, enclose ko lang siya. Lumpia. No? Lulumpiahan mo lang yung lulumpiahan mo lang itong charge mo. Okay. So, ayun yung surface ko yung green. Okay. And then, we'll just follow our steps. Number 2. Cylindrical surface. So number 2, we'll write down the left-hand side. Left-hand side is just your problem, which is E. And then your surface area. What is the surface area for a cylinder? Okay, so nandito ba si Ran? Are you there? Okay, wala. Tapos si Ran. Si PJ. Ano yung...
H,
Sige,
sir?
go. Okay, yung H natin, ano yung H?
Yung ano, sir? Ano, sir? Ulit, question?
Ano yung H? Ano yung definition mo ng H? Kasi wala tayong ano dito, wala tayong definition ng H dito. Well, wala rin naman tayo ibang definition. Ito lang yung mga defined ano natin. So I'll give you the liberty to define H. What is H?
S? Sure.
Hindi, wait, ano yung, di ba, ano yung binigay mo sa aking answer?
Ano, 2 pi RH ata.
Okay, 2 pi RH. Sa ano mo, sa definition mo ng R at H, ano yung R, ano yung H? So yung R ay
Radius.
radius nung cylinder, tama?
Yes, sir.
Okay, nung H ano ay
Height ng cylinder. Pero
length
dito
ng
kasi
cylinder.
dito kasi sir, di ko alam kung ano yung length
Okay.
ng cylinder.
Okay, so that's okay, no? Okay, thank you, PJ. Dito sa problem natin, dahil kung titignan natin yung likod ng libro natin, yung gamit sa cylindrical coordinates is that yung S will be your, doon tayo ng rainbow, yung S will be your radial component, so that's S. And then yung Z will be this guy, yung haba mo. And then yung phi will be the rotation around the cylinder, which is just this guy. So this is phi hat. Okay, get? So yung Z will be your height, and then your S will be your radial component, and then yung phi will be the rotation around the cylinder. Okay, so tama si PJ no na yung left-hand side natin or yung surface area natin for a cylinder has to be 2 pi r, 2 pi RH, pero in our case, oops, that's colorful. That's too colorful. That's 2 pi r, 2 pi s sa case natin. And then, you can say z, but i-reserve natin yung mga coordinates natin for variables. So I just write an arbitrary length, which is L. Okay, I can write down Z. No? Maarte lang ako. I can write down Z, pero maarte lang ako. Because I want to reserve X, Y, Z, R for variables na nagbabago-bago. Okay, so I just write down L dahil hindi naman nagbabago yung length ng cylinder natin. Okay, we have the left-hand side. And then we have number 3. Oops. Number 3 will be your right-hand side, diba? Right-hand side. Okay, and then the right-hand side will be the total charge that is enclosed. Now again, pwede natin lakihan yung imaginary surface natin such that the total charge is enclosed. So kailangan natin mahanap ngayon what is the total charge. The total charge is given by Q total, and that is the integral of your charge density, which is rho, and then the tau. What is rho? Ks. What is d tau? Lagyan mo na natin prime, no? Para hindi tayo malito. Prime. Okay, so what is d tau? Okay, tatanungin tayo syempre. Si Danny are there. What is d tau for cylindrical coordinates?
Yun po ba yung may ano pong tawag dun sa d theta ba yun? Or DZD?
Sige, sabi mo sa akin.
Wait lang, sir.
Nasa likod ng libro.
Wait po.
Andun yan. Sige, basta mo yung libro mo sa dulo. Dulong-dulo. Tapos kunin mo lang yung d tau for cylindrical.
Wait lang. Oh my God.
Hindi mahanap?
Hindi po.
Okay. Okay, may tanong si Jello pero madadaanan natin to. Okay, so tulungan mo si Danny, Kyla.
Sige po, sir. Sa dulo po nag-boxer, di ba?
Oo, nasa dulo yan. Alam ko naman na pero gusto ko makita nyo. Okay. So, KS prime yung ano natin, yung charge distribution. So, ano yung detail for cylindrical? So, ano nangyari? Kyla, nahanap mo? Hindi. Nakamute ka?
Hindi ko pa po mahanap, sir.
Okay.
Nasa may units po ba yan na chapter?
Sa dulong-dulo ng libro. Okay. Si Irish may sagot. Okay. Sige, okay na Kyla. Ayan. Ayan. RD theta, DZ. Okay, so, ganun, no? Pag nahihirapan kayo sa detail, isa-isahin nyo lang. Okay? Pag radial, madali lang siya. Pag along the coordinate, madali lang siya. So, we have ds prime and then ds, ay dz. Kasi, yung mga yan ay directed along coordinate, which is z hat and s hat. Ang problema mo ngayon is yung mga nagro-rotate na variable. Nagro-rotate na variable, kailangan mo siyang multiplyan ng factor such that mabubuo mo yung okay, so may tanong si Ross at Jello. Ang galing ng mga estudyante. Ang galing talaga. I love it. Natatanong niyo yung mga bagay na i-discuss ko pala. Okay, so yung last na coordinate natin will be DC, but arc length is para mag-make sense siya, kailangan arc length kukunin mo. Kasi pakurba yung P hat mo. Okay. So para makuha yung arc length na yan, kailangan mo yung kung gaano siya kalayo and then yung angle mo, which is dp. So ito ay S prime dp. Okay. So ayan, aralin nyo yan. So para next time di kayo malilito. Okay. So yung S prime mo will run from your origin to the radius, which is S. Kaya tayo naglipat sa S prime para hindi tayo malito sa mga variables natin. Then yung Z will run from some arbitrary length. Again, I pick L to be arbitrary. And then C will be just your complete rotation para mabuo yung cylinder. Tama? Okay, so yung complete rotation na will be just 0 to 2 pi. Okay. So now, okay. Since para masagot na yung mga tanong ng mga nagtatanong, Sir, bakit yung kinuha natin na surface area dito is just yung lumpia wrapper mo lang? Bakit hindi natin consider yung mga nandito sa gilid? Okay? Okay. Okay. So bakit nga ba hindi natin kinopya yung nasa loob? Ang kailangan natin will be the electric field inside the cylinder. Tama? Okay. And then, we didn't want to close hindi natin kailangan i-close yung lumpia natin sa gilid kasi kung mapapansin nyo, magka-cancel yung kabilang ends. Okay? Okay, so hindi na natin siya kinlose, number 1, kasi magka-cancel lang yung ends mo. Okay? yung pag-increase ng surface nung charge density mo rho is along that direction. So yung nandito sa mga dulo ng lumpia mo will be the same as the other end. Okay. So with that, so yung kailangan mo lang na imaginary surface is the wrapper. Ayan. Okay, so ba't hindi yun nag-contribute dito, sir? Kahit na, di ba? Okay, kasi kung mapapansin nyo, yung mga nilalagay lang natin sa left-hand side will be E.dA. And for E.dA to have value, dapat yung surface mo, which is yung itong lumpia na green, yung lumpia wrapper mo, dapat perpendicular yan sa field para magkaroon ng value, which is itong radial part lang. Okay? Parallel tong green mo, yung surface mo, with the fields that are coming out dun sa edges, sa bases. Okay? So does that answer the question? So ito lang yung kailangan natin. Okay. So we continue to integrate this problem. And then we continue this. So dahil yung problem lang naman natin dito ay S prime lang, we can easily integrate dphi and dz. So we have, for your dp, dphi, k, 2 pi. Nilabas ko lang yung k, tapos yung 2 pi mo is your phi value, and then L for your z value. You're left with S prime squared. Dahil may S ka dito for your arc length, and then S with your charge distribution. Then we integrate S prime. This is trivial. The integral is trivial, so we have K is equal to, this is equal to 2 pi L S cube over 3. Tama? Okay. Okay. Oops. Okay, so this is your right-hand side. And what's left for us to do is combine things. So we have your E, then your surface, yung wrapper mo, which is 2 pi S times yung length mo. And then that is equal to the total charge enclosed, which is just K 2 pi L S cube L S cube, oops, 2 pi L S cube over 3. Tapos epsilon pa dapat, di ba? Kasi 1 over epsilon na times yung Q enclosed. Okay. And this simply gives me, I just divide things. So cancel 2 pi. Magiging K over 3 epsilon. K over 3 epsilon S squared, tama? Cube minus S. 3 minus 1. Okay, so S squared, sorry. Cancel mo, sir. Then cancel yung L. Cancel din pala yung L. So the length doesn't matter for this problem. And then we know that the electric field is straight radial. Okay. 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 So ito ay nasa example din sa libro. You can review it. Okay. You can review it para madalian yung buhay mo. Okay. Lastly, we have another one. So for an infinite plane that carries a uniform charge surface sigma, hanapin natin yung electric field. Okay, so uniform charge sigma, and then we have your field. Red natin para uniform tayo. So, nagluloko na naman siya. Ayaw sa akin. Again, ayaw naman sa akin yung panulat ko. I have to close the screen again. Wait lang, guys. Then, okay, tuloy tayo. Sorry. Then, daming technical difficulties. Okay, kita na ulit. Kita na. Uy, may prophet. Okay. So, tuloy natin ang red, pili tayo red. Then you have your plane. Okay. Sir, clarification po, ano po ba talaga pinagkaiba ng Q total at Q enclosed for a closed surface? For a closed surface, yung Q total mo, nagiging Q enclosed lang siya. Kapag yung in-enclosed mong surface, yung imaginary surface mo is less than the radius of your thing. Okay? So since naman na sinabi nating arbitrary, itong arbitrary yung problem natin na ginawa mo na lang na ito siya Q total, I can say that magiging enclosed to kapag binawasan ko si S. Okay? And pwede kong ma-reduce yung total mo by just limiting your integration or your surface mo. Okay? So yung naglilimit sa Q total tsaka Q enclosed is yung surface mo na i-imagine. Yung ginagamit mong surface. Okay? Let's close D. Okay, so let's give an example kung kailan siya nagiging useful. For points of side, okay, kuwari for a solid sphere. For a solid sphere, kung gusto mong kunin yung, if you wanna get the field for R greater than R, you'll need the total. Is needed. Okay? And then for R less than R, capital R, sorry, small r less than capital R. So yung R mo, yung capital R mo, yung radius ng sphere. For points that are inside, ang kailangan mo is lang yung Q enclosed. Okay? Needed. So there's no nothing limits you to write the final answer in terms of the total charge Q, total charge. Still you can write the final answer. Answer in terms of Q total. Okay? Malinaw ba yun? In general, sa Gauss's law, ang kailangan mo is Q enclosed. Okay? Okay, so let's continue. Continue. Meron kang infinite plane na meron siyang charges dun sa plane na yun, syempre. And then you have first to imagine what field it produces. Okay? So yung field na to. Bigyan natin ang ganito para alam natin nag-joke. So nag-extend siya to infinity. Okay, so yan. Extend siya to infinity. Maniniwala ba kayo sa akin na yung field nito is upwards all over the place? Uniform. Upwards and downwards, of course. So, ang field nito, kapag tinignan natin sa side view, will be something that is like, so ito yung plane mo. So, ayun yung plane mo. Ang field mo will be going up, going up. Okay? Bakit ganito? So, balikan natin yung problem natin na last time. Yung electric field para sa isang limited rod lang yung rod. Tapos tinignan natin that yung field at this point, diba? Sinolve na natin ito nung una. Yung may trigonometric integral, yung substitution integral, na yung at this point, P, yung E mo dyan is just C. Because yung part nito will cancel out with this one. Cancel out. Cancel out. Cancel out. Cancel sila. Okay? So that makes sense, di ba? So pag in-extend natin yun sa isang plane natin, which is this, tapos infinite pa siya. So pwede mo siyang isipin na ganito. Equal yung nasa right niya at nasa left niya. Kaya siya nagka-cancel yung mga horizontal components mo. Kasi at the right-hand side, meron kang plus infinity, na distance, meron kang sa kabila ng minus infinity, and they would just cancel out. Tama? So, ayun ay, ang field mo lang is just upwards. So, what surface are we gonna use in this problem? So, ang kailangan nating surface dito is that yung surface mo has to be perpendicular to the field. Yung fields mo ay upward and downward, so I want to place a box here, and a plane, and another one at the bottom. Okay, so imagine nyo lang. Another one at the bottom. And then, I can close them. I can close this box. Since itong mga boundaries or gilid ng box ko is parallel to your field, and that contributes nothing to the answer. So yung magko-contribute lang will be the top part and the bottom part. Okay, let's say that the area of this square is A. Okay. Yung sides, wala na akong paki kung gano'n sila kalaki. Doesn't matter, di ba? So you just write down the problem. So I have E, then the total area, which is 2A. Tama? So ayun. And then, from that, ano yung enclosed ko na charge? So we are given by sigma, Q enclosed, and that is epsilon. Now, can we get the Q total? We can get the Q total, di ba? It doesn't make sense kasi ito ay infinite plane. Ano yung charge, total charge na infinite din, di ba? So kukuha lang tayo ng portion niya lang kung ano kaya lang natin ma-close, which is A lang din, di ba? So sigma A. Tama ba? Nakuha na sigma A yung total, yung closed and enclosed charge. Di ba? Kasi ganito kalaki yung box mo, di ba? So makukuha mo lang din at this point. Edi yung yan lang na part lang. And that square is just A lang din, di ba? Kasi A itong nasa taas, A itong nasa baba. Definitely yung gitna nila A lang din, kalaki yun. It's very simple. Our answer becomes sigma over 2 epsilon naught. Okay. Joke. Mali pala itong equality ko. Try natin para ay nalilo ito. So, E has to be sigma over 2 epsilon naught. And yung n hat natin will be the vector that is guiding your plane. Okay? So, in general na lang, no? Baka kasi mamaya nasa xy plane siya, pwede yung maging z hat. Kung nasa xy plane yun, kung nasa yz plane naman, magiging x hat, etc. etc. Okay, so we have this electric field. Mapansin natin constant nung galing for a plane, infinite plane, nagiging constant yung electric field natin. Kaya that makes sense na maraming flat earthers. Kasi kung mapansin nyo, dahil malaki yung radius ng Earth, yung tinatayuan natin para siyang infinite plane. So yung gravitational force na nararamdaman natin is just upward or downward, diba? Upward, isang direction lang. So pag binagsak mo yung gamit mo, hindi siya pumupunta sa kanan or pumupunta sa kaliwa. Pababa lang. So parang marami nag-iisip na, ay, nasa flat Earth tayo. Okay. Dahil dito sa mga ganitong equation. So pag pumunta ka sa Mount Everest, ang mararamdaman mo, humihina na yung field mo. Okay. Okay, so yun, no? Ganun pag, so yun yung silbi ng Gauss's law. Galing, di ba? Ang ikli lang ng mga solution natin. Umahaba lang dahil kasi namin ko sinasabi. Isipin mo, nakapag-solve tayo ng 3 problems agad. Dali lang yung ginawa natin. Okay, so gawin natin to. Meron pa tayong gagawin. Tuloy natin, no? Tuloy natin yung nagagawa natin in real life. Okay, so basahin natin. Gawin natin yung problem 2.11. Use Gauss's law to find the electric field inside and outside the spherical shell of radius r that carries a uniform charge, surface charge density sigma. Compare your answer to problem 2.7. So yung problem 2.7 ay yung or set nyo last time. Tama? Then problem 2.8 and din yung number 2 nung problem set nyo. So tingnan natin kung gaano kadali masasolve ng Gauss's law yung problems natin. Okay, so tuloy natin. Mabilisan lang to ha. So follow kayo. Okay. So inside and outside. Okay, so outside muna. R greater than R. Okay, so si R, small r, will be your imaginary surface na pwede siyang mag-variable, pwede siyang lumaki. And then yung R, capital R mo, will be your radius of your shell. Okay? Okay? Okay, so I'll write down my left-hand side. What is ang gagamitin ko for this problem is sphere, spherical shell din. Kasi spherical yung symmetry ng problem natin. So, I have 4 pi r squared. Tama. Tama. And the right-hand side will be Q enclosed. 1 over epsilon naught Q enclosed. And what is your Q enclosed? Ano yung may enclosed yung charge? That will be the whole sphere kung lalakihan ko yung r ko. Kasi mas malaki tayo greater than tayo sa radius ng problem natin, di ba? So the total charge will just be sigma times yung surface area ng shell natin, which is sigma 4 pi r squared. Tama? Tama. And this is just arrow E will be 1 over 4 pi epsilon naught. Then r squared, small r squared, then sigma 4 pi r squared. And this whole thing is just Q total. Okay, ito yung problem set mo. Tapos na, di ba? Outside. Dali, di ba? Tama, Q total to, di ba? Kasi na-enclose mo. Fortunately, na-close mo. Is just yung total. Okay, so inside. Same thing sa left-hand side natin. 4 pi r squared pa rin. Dahil spherical shell pa rin yung imaginary surface natin. Then 1 over epsilon naught. And then what is the Q enclosed? Q enclosed. Okay, what is your Q enclosed? Is there a charge inside the problem? Doon sa ano natin, di ba? Ang problem lang natin, meron tayong spherical shell of radius r na merong charge density sigma. Inside of that, walang charge. Okay? Walang charge dun sa loob. So this becomes 0. And you have 0 inside. Okay, so nagawa natin yung problem set nyo in 5 minutes. So yun yung power ng Gauss's law kapag may symmetry. Amazing, di ba? So ito pala ay may r hat. Okay. Okay, last 2.12. Okay, so inside a uniformly charged solid sphere, charge density rho. Compare your answer to problem 2.8. Okay. So r less than r na naman tayo. I have 4 pi r squared, tama. Ganun pa rin yung makukuha ko, di ba? And then 1 over epsilon naught. Then Q enclosed. Q enclosed. Oh, may charge density rho tayo. Gamitin natin. Uniform charge density rho. So I have sige. Let's take it slow. Q enclosed. Okay. Ano yung Q enclosed sa loob ng sphere? Okay, dahil ngayon meron ka ng this is a solid sphere na. Meron ka ng close na portion ng sphere mo. Okay? Dahil R less than capital R tayo, sure na may enclose ka. And that is just 1 over epsilon naught. And feel ko marami naman nang gumawa sa inyo nito. What is the charge enclosed? So yung volume ng sphere mo, check. Volume ng sphere mo will be, okay, para malinawan lahat. Some portion of Q total. Okay? So, dahil R less than capital R, yung Q enclosed mo will be some portion of the Q total. And that is just 1 over epsilon naught. You can do the integral, pero na natin pahirapan sarili natin. What is the total? Yan natin ng Q total. So this must be a fraction less than 1. Tama. And to do that, we have 4/3 pi r cubed. Okay, this is the volume. Then we have 4/3 pi r cubed. Okay. So when this is r, makuha mo yung total. Tama? And when yung r mo is in the origin, it's 0 out to, and wala kang makukuha. Makes sense, di ba? Makes sense. And then we have cancelled out. We are left with one over epsilon naught. Tapos r cubed over r cubed. Small r cubed over capital R cubed. Q total. And then your E has to be this guy. Tapos r cubed over Q total. And then you divide by the surface area of the shell, the imaginary shell mo, and that is 4 pi r squared. And this has been your solution for your problem set. Ang dali, di ba? Ang lapit naman ng Q total. Tapos R, R hat. Naalala niyo? Ayun yung sagot niya. R cube. Okay? Magka-cancel yung R squared sa R cube. Matitira na lang R. Tapos radial yung electric field mo. So, ganun yung power ng Gauss's law. Na dumadali ang buhay mo. Okay, sa pag-solve. So, honey, anong mas gusto mong gawin? Yung mag-integral o mag-Gauss's law na lang?
Yung mag-Gauss's law na lang
Diba?
po.
Amazing. Ang dali lang kasi, di ba? Ang problema nandito sa Gauss's law, problem specific siya na kapag kailangan mo ng symmetry, kailangan mo cylindrical siya, kailangan mo planar siya, kailangan mo spherical siya, ganun ang requirement niya. However, again, you can invoke superposition to solve for problems na may symmetrical objects. Kuwari, you have a plane, then you have a sphere. So, mahirap pa rin i-solve yun gamit yung integral mo. But you can solve that by using Gauss's law. So, mag-a-add lang yung electric field due to the sphere and then due to the plane. Diba? Superposition. Okay, so you have a prob set. Okay. So, madali lang tong prob set na to. Okay, so may tanong. Sir, lagi pong hollow dapat yung imaginary surface na gagamiting reference. Ano nga hollow? Kailangan closed. Number 1, kailangan closed yung kailangan closed yung surface mo. And then, ayun, kailangan closed yung surface mo. Tapos dahil surface area siya, yes, hollow siya lagi. So, hollow sphere, hollow box. Kasi hindi siya volume. Okay? Hindi ko alam kung tama yung pagkakaintindi ko sa tanong mo. Sorry. Okay. So, yun. So, may problem kaya 2.16. Then, 2.18. Ito yung sinasabi ko, may dalawang sphere. Okay. So, you can use Gauss's law in each individual. Right? And then, probably mo gamit yung superposition dito. Alright. Then, 2.16, combination to ng coaxial cable. So, ibig sabihin no, meron kang inner cylinder na volume. Bale, meron kang lumpia. Ayun, tapos meron ka sa labas, may outer cylindrical shell naman siya. May wrapper siya. Okay, so sorry. Nag-crave lang siguro ako ng lumpia. Okay. So tuloy tayo na. Hindi tayo tapos sa problema natin in life. Dahil divergence and curl na yung hinahanap na natin. So di pa tayo tapos. Curl naman ngayon. Okay. Okay, so let's say that we have a charge at the origin and we know that the electric field of that charge is simply given by this guy. Okay? Makes sense, di ba? 1/4 pi epsilon naught yung charge Q mo, then over R squared. Okay, that makes sense. Nakita nyo ito lagi sa mga sinasolve nyo. Okay? Ayan. Ang gusto natin gawin ngayon is kunin yung curl ng curl ng E. Okay. Check ko lang notes ko. Curl. E. Okay. Pangit yung curl ng E. Okay, so we have this guy. We have this for charge Q at the origin. And then we can solve for the curl of E. So pwede kong palitan to. Kunin ko lang to. Then I have del cross E. Palitan ko lang si V, no? Para tayo mahirapan. Then that D8. Then I have to write on the right hand side as the closed integral of a path and then E dotted with the L. Oops, sorry. DL. DL vector. Okay. Okay, yan, di ba? Tama naman. Wala namang kulang. Okay, so using the fundamental theorem of curls or Stokes theorem, ito, yun. I can just solve for this right-hand side. Then, baka makuha natin itong curl ng E. Kasi pagod na tayo in life, huwag na tayo mag-curl. Napakahirap mag-curl. Daming terms. Huwag na tayo mag-curl. Okay, so let's do the closed integral. And then we plug in our E, which is 1 over 4 pi epsilon naught. Then Q over R squared R hat dotted with DL. Okay. So what is RDL? What is R? Okay, sige, magtatanong na lang ulit ako. Nandito na ba si Ran? Ayun. Wala ata si Ran. Sad. Si Pam na lang. Si Pam. Hello, Pam.
Yeah.
Ano yung DL for spherical coordinates?
Yung DR.
Nasa likod ng libro. Sorry.
Yung po bang DRR hat or D theta hat plus R sine.
Ano? Pakiulit. Sorry. Slowly. Mabagal lang si Sir.
Ano po? DL is equals to DRR hat.
Okay, DRR hat.
Plus R D theta hat.
Okay.
Plus R sine theta. D, ano nga po yung?
Phi yan.
Phi hat.
Okay. So sa problem natin, ano yung useful lang sa tatlong terms na yun? Ano yung kakabit sa R hat mo pag dinot product? Nakamute ka, baka nagsasalita ka.
Yung theta po ba at saka yung phi?
Ano? Sorry. Pakilakas yung boses.
Yung theta po ba at yung phi?
Hindi. Ang kailangan lang natin, guys. Okay, so remember this Pam. Dahil dot product tayo, yung kakabit lang kay R hat is yung R hat lang din. Okay, so I'm left with over 4 pi epsilon naught Q R squared. And then R hat to, then may R hat pa ako. This is just 1. Okay, so tanggalin ko na yan. Kung pagulo lang. Okay, balik natin. Amazing. And let's solve this integral, no? Madali lang to trivial. This is just 1 over 4 pi epsilon naught. And then negative Q over R. Tama. Kasi magiging R negative 2, tapos integrate mo yun, magiging negative 1, R raised to negative 1 over negative 1. So that's this. And then you'll have to integrate it over some path. Okay, so integrate mo siya along some path. Okay. And arbitrarily, I can just say that this is A to B. And that gives me, labas ko na si Q over 4 pi epsilon naught. And then, this is just, evaluate ko si B, then evaluate ko si A, tapos minus ko sila. Ang lalabas dun is 1 over A minus 1 over B. Tama? Nagpalit sila kasi may negative sign. But however, ang kailangan sa akin is closed integral. So when you have a path that's starting at A, B. But if you have to close it, babalik ka sa A. So 1 over A minus 1 over A, 0. So yung E.dl ko is actually 0. Okay? So 0. And then if I equate it to the left-hand side, this tells me that the del cross E, or the dA, and yung ito yung left-hand side natin ng Stokes theorem, I know that dA is not 0. Diba? Hindi naman ito nag-zero out. Laging may area. And then, ito na lang yung pwede mag-zero out. So, for charges, we have the curl of E must be 0. Okay. Okay. Is this true for general? In general case, no? Kuwari gumawa ako ng Mickey Mouse shape na charge distribution. Okay, so si Mickey Mouse, kung lagyan ko siya ng charges, I know for sure that for one charge, ang del cross E ko is 0. Okay? So what is the field for this whole configuration, for this whole Mickey Mouse? Diba, by superposition, yung E total na to, total will just be the sum of the individual electric fields dahil may superposition tayong thing. Okay? And then, if I plug in E total here, E total, I would just have yung del cross E1 plus del cross E2 and so on. Hanggang sa dulo para mabuo ko yung Mickey Mouse ko. Ay, sorry. ER. Okay? Para mabuo ko tong Mickey Mouse ko. Okay? And we know that every charge is just 0 to 0 plus 0 plus 0 and so on. So for any charge distribution, you can say that the curl of E is 0. Okay? Okay. For any charge distribution that is not moving. Static charge distribution. Distribution. Okay? Okay? So nasa electrostatics kasi tayo. Electrostatics. Okay? So lahat ng charges nun di gumagalaw. And we have del cross E for that. Tapos magiging 0 lang yun. Okay. So ang implication lang nun is that yung right-hand side ko, okay, so if this is true, then my right-hand side is true, which is E.dl, the closed integral, E.dl is equal to 0. Okay? Okay, so ano implication nito? May familiar ba dito sa magandang equation nito? If you're not familiar with it, this is the statement for Kirchhoff's. Oh my God, I'm so sorry, Kirchhoff. Hindi ko alam spelling ng pangalan mo. Okay, so Kirchhoff's. Dalawang H ata, but okay. You get the point na voltage law. Voltage law. Na kapag umikot ka around your circuit, dapat yung potential difference mo will be 0. Okay. So ito yung implication nun. So when you have the curl of E that is 0, you are free to formulate a potential na kapag kinlos mo magiging 0. Okay? So in yung next topic natin, which is the electric potential. Okay? So lesson 4. Kala nyo tapos na. No? Dita, may 30 minutes pa tayo. The next topic natin will be the electric potential. Okay, so may prob set tayo sa kabila. Okay. I-upload ko naman. Again, may prob set, which is this guy, 2.16 and 2.18. Okay, continue. Sir, di ko po gets kung bakit naging ganun yung DL sa dulo. Where is the problem for spherical? Kung bakit naging DR ba? Yun ba yung tanong mo? Okay. So, okay. I have to slow down. So, ganda ng color natin. So, note na lang natin. Blue na lang tayo, okay? Blue. DL hat for a general path in spherical coordinate system is given by, nasa likod ng libro nito. So, for any path to, no? Any path, R hat plus R d theta, theta hat, sorry. Then R sine theta for your phi, d phi hat. Let me check if I'm correct. R sine theta. Okay, in general, ito yung path mo in spherical coordinates. Okay? Ito ay arc length for your RD theta, for your theta coordinate, and R sine theta is your arc length for your phi. Okay? Okay, so ito yung general path mo. And then, ayun. Okay, so for any problem na may kailangan ng DL, tapos kailangan mo ng spherical coordinates, ito yung kailangan mo. Okay? And then, from here, i-dot product natin si R hat, yung radial component natin, to your DL vector. Okay? So, pag dinot product natin to, magkakaroon tayo ng 3 terms, tama? R hat, dotted with R hat, TR, and then, comma, R hat, dotted with theta hat, R d theta, and then the other term, the last term, gives me R hat dotted with phi hat and R sine theta. Okay? And from your mathematical preliminaries, itong mga dot products mo na to, since they are perpendicular, they just zero out. Okay, so yung natira na lang is yung R hat, which is pag parallel sila, dahil parallel to magiging 1. Okay, so that's what happened here. Kuha na ba? Kaya siya na lang yung natira. Okay. Sir, bakit po ulit naging 0 yung sa may closed integral? So, balik tayo. So, ito ay tinuloy natin. Integrate ko tong part na to. Then, I'm left with this. So, ginawa ko na munang generalized yung integral ko. So, that means that I will choose my bounds arbitrarily from A to B. Okay? So, I have this. Okay? Tama? Gets pa up to this point? Gets pa ba up to this point? Okay, so gets pa hanggang dito. Ang problema, ang kailangan kasi natin will be a closed integral. A closed path. Okay? And then, ang path mo will be arbitrarily. Kuha tayo ng path, random path. So, I have to go from, yan. This is point A, and this is point B. Okay. And then for this to be closed, para ma-close mo yung path mo, kailangan bumalik to your original. Kailangan, di ba, ito yung closed na shape. Di ba, hindi pa to shape. So, para maging shape siya, para maging closed siya, babalik ka to your starting point. Tama? Make sense, di ba? And kung ito rin yung B mo, we have B is equal to A. And then, plug in ko yun. Plug in ko yung fact na yun nandito. I'll get 0. Nalinawan ba? Baka hindi ko nakukuha yung questions. I'm so sorry. Does that make sense? This is different from what we have been dealing before. Kasi this is DL and di tayo usually gumagamit ng DL. Gamit natin DA, which is a closed surface that is like a spherical shell, a cube, a cylinder na may takip. So yun yung mga DA natin. Closed sila. And yung DL mo, pag kinlose mo yan, magiging some weird shape siya. I mean, pwede naman circle, kung gusto natin circle. But the point is, parang magbabaliktad lang, sir, yung bonds. Kaya po magka-cancel out. Magbabaliktad lang yung bonds. Ang magiging bonds na ngayon. Okay, A to B pa rin yung bonds mo. Tama? Okay. A to B. Pero ngayon, si B mo kasi, if you're gonna move this guy, so cross out na natin siya. So hindi na ito si B mo, endpoint mo. So kasi si A ay start point mo, then si B yung endpoint mo. If you're gonna do that, you start from A, then si B yung kung saan ka mag-end. Para ma-close mo yung isang line, kailangan mo bumalik sa simula, di ba? Para maging close siya. And doing that, babalik ka sa starting point mo, which is A. So magiging, yung bonds mo will be, sulat natin dito. So sulat natin dito, Q over 4 pi epsilon naught. 1 over A minus 1 over B. Your starting point is A, then yung end point mo is B, tama? But if the integral has to be closed, then B should be the same as A. Okay, so magiging A din to. And in the end, 0 siya. Okay, okay. Okay. Klaro na ba? Klaro na ba? Okay, okay. Okay. Gets na. Okay, so balik tayo sa kabilang lesson. Electric potential. No? So, ito. We will define the electric potential as something like this. Okay. Kita nyo? Sorry. Bukas pa pala. Okay, so we define the electric potential as this guy. And then makapansin natin yung form niya ngayon is hindi closed. Okay? Okay. So for an arbitrary point, let's say VB, ang makukuha natin is negative. Papalitan mo lang yung mga R ng B. Tapos yung, etong shape na to, yung O, is a reference point that can be arbitrary. Okay, so lagay ko lang na muna na ganyan lang as siya muna. Okay? So, okay. So yan, we have this guy. And then let's say we have another, which is VA. That is this Marting O. Yan natin Arting O. And this is A. E.V. Okay, anong meron? So let's get the VB minus VA. VB minus VA will be the negative integral from the arbitrary point to B, E.dl. Then minus, dahil ito ay minus din, so minus siya, magiging plus. Minus. Okay. Okay. And this is .tl. Tama. Okay, so far so good. Ano lang tayo, nagma-minus lang tayo ng bagay-bagay. So, ayun, may mali. Ayun ba yun sa... Okay, so ito ay VB minus VA. Minus VA. Okay? Okay. Mali ako doon. And then, i-absorb ko yung negative sign dito sa negative, sa left term ko. So, I'm left with B to some arbitrary point. Then I have A B dot B here. Okay? Wala namang... So pag inabsorb ko sa integral ko yung negative sign, magpapalit lang sila ng integral bounds. Fairly straightforward. Then, if you look at this, alam nyo to. Dapat alam nyo to. Na pwedeng pag-combinein tong dalawang integral na to form EA B dot dl. Okay? Dapat sa math to alam nyo. Okay. So, ayan. From here, pwede ka rin mag-split ng integral, no? Into some arbitrary points. Oh, okay. Yan. Pwede siya maging dalawang integral. Okay, so anong sense ko? Ano gusto kong point out? So this is VB minus VA. Kuha. And then if we're gonna use the fundamental theorem of gradients, so this is also VB minus VA, and the right-hand side is different. So kung ito ay VB minus VA then these two shall be equal. So this has to be also integral of del V del V, yung potential mo. The gradient of V dotted with DL. Dotted with DL. Okay. Tapos A to B. Kuha. Then let's make it look dissimilar. I'll switch this so I have negative E, A to B, dotted with DL. Ba't tumatagal yung sulat? A to B, del V, dotted with DL. DL, the same. The integral is the same. Therefore, the process is the same. Therefore, we have E is equal to negative del of C. Okay. Ayan yung electric potential mo can be written as something that's like this. Okay, anong implication nito? Anong pinapahirapan nyo lang kami, sir, ba't may bago na naman tayong sinasabi? Okay, anong implication nito is pwede kayong mag-solve ng potential V, then from that, you can get the electric field E. Okay? Si V, scalar function yan. Scalar function si V. Si E, vector function yan. Di ba ang hirap mag-imagine ng mga bagay-bagay kapag may vector function ko? Tapos, what's that? Lesson 2. Kunin natin lesson 2. Yung electric field mo, may, ayun, yung curly R hat. Pinoproblema mo yun lagi, di ba? Kasi ini-imagine mo kasi siya nakatutok. Sa V mo, scalar siya. Wala siyang mga hat-hat sa loob. Okay? So let's take that into mind. Okay, so notes lang muna tayo. Yung potential hindi yan same sa potential energy. There's a different potential energy na tatalakayin natin next meeting. Okay? So yung potential formulation natin, itong mga bagay na ito, nag-e-exist lang to dahil sa sinabi natin del cross E is 0 and the closed integral, the closed integral E dot TL is arbitrary. is the same for all paths. Kahit anong random path kunin mo, mag-zero out lang yan dahil kinlose mo nga siya and sinasatisfy niya Stokes theorem. Okay. Yung reference point natin is arbitrary. Okay. Yung O, pwede mong piliin as infinity, pwede mong piliin as zero, kung saan babagay yung problem mo. So, anong implication pag nagbago yung reference point mo. So, kung wari mayroon kang V of something, V of R, pag in-evaluate mo siya somewhere na yung okay, so yung kuwari, pinili mong reference point is some arbitrary point. Ang mangyayari lang sa potential mo is magkakaroon siya ng constant K. And kapag kinuha mo yung VB, as long as you are consistent, VA, magiging VB plus K, tapos minus VA plus K. And magpapansin nyo, maka-cancel out lang yung constant na naradagdag kapag pumili kayo ng arbitrary reference point. Okay? Okay? So, ganun pa rin. Okay. So, tapos yung potential mo, just like the electric field and the forces for charges, nag-obey din siya ng superposition. Tapos, ang units natin volts. Okay, wala lang. Fun fact. Okay, so you can read more about this in your book. For now, we're gonna find the potential. Actually, ano mas maganda solving? Okay, sige. Gawin muna natin 2.7. Mabilis lang pa. Okay? Okay, so the electric potential for a nakabukas ko lang. Okay, so solve natin yung potential inside and outside a spherical shell of radius r that carries a uniform surface charge. Set the reference point at infinity. So, kailangan natin is this guy. Okay? So, V of R. So, V of R is just negative some reference point then to R E that dl. Okay, so nag-stay tayo sa R dahil radial naman yung problem natin, spherical. Walang problem doon. Okay? And then we know from using Gauss's law, wow. Dayang, sir. Using Gauss's law, ang field natin for this guy, for R greater than R, sa labas, ibig sabihin, is that we have 1 over 4 pi epsilon naught. Then the total charge Q all over R squared. Tama? I mean all over small r squared. Okay. Small over r prime squared. Okay. At t prime. Okay. So prime muna tayo dahil may r tayo dito nakakalito. Okay, so yung dl prime mo, again, this is a vector, sorry. Yung dl prime mo will be yung pinasagutan natin kanina na yung rdr something for spherical coordinates. dr r hat pala. So ito ay r hat plus r d theta hat r sin theta d hat plus. Okay? So ayan. So ang matitira lang ulit ay ito ay may r hat. Sorry. R hat. Matitira lang is yung may r and then you're left with the integral becomes r over 4 pi epsilon naught q over r prime squared tapos dr prime, tama? And this is simply 1 over 4 pi epsilon naught tapos negative and then we have q over r prime evaluated from to R. Okay? Sabi ni problem, I'll use the reference point at infinity. So I have to plug in infinity here. And then this is just 1 over 4 pi epsilon naught. And then I'll evaluate, of course. Gawin ko na itong Q para hindi tayo mahirapan. Q. Okay. And then this is 1 over R minus, oops, may mali kasi. Dapat negative to. Tama? Okay? Okay, so dapat tayo negative. Ito ay positive. And this is just 1 over infinity. What is 1 over infinity? That is 0. And we have 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught. Q over R. Okay. Okay, check ko lang. Electric potential. Double check ko lang guys para ano tayo. Okay, tama naman ako. Makes sense, makes sense. And then next is inside. Inside, no? Mag-solve tayo inside. Inside. For R less than capital R, then dahil yung gusto ni problem natin, solve tayo from infinity to R, so pi epsilon naught, Q over, kopyahin ko na to para mabilis tayo, kasi alam naman natin same lang yung DL dahil spherical coordinates pa rin. Same lang yung mangyayari problem. I'm left with this. However, and this is wrong. And mali yan. Okay, bakit? Kasi yung field ko sa labas, E outside. Yung field ko sa labas is this guy. Sulatan natin din. So yung field ko sa labas, this guy. However, yung field ko sa gitna dahil ang problem natin ay spherical shell, diba? Gamitin natin yung Gauss's law inside, walang charge inside. So, 0 inside. So, dalawa yung integral natin. So, I have to rewrite things up. So, we have, use the blue one. Dahil ito ay this guy. Puputulin ko hanggang sa labas lang, hanggang sa shell ko lang. Dahil I know from this region, ang mangyayari ay magiging Q over R prime squared dr prime. Tama. And then inside plus minus, so that's minus 0 to R. Tama? Tama ba? Oops, baliktad. Baliktad. Mali ang ginagawa mo, sir. Oops, ay mag-undo. Iburahin ko na. Okay. Kaya mali yan. Dapat ang lalagay mong bounds will be from your radius, sa radius na sphere mo, papunta dun sa tinutukoy mong problem, which is yung small r. Okay? And again, the electric field inside is 0. E.dl. Dahil for Gauss's law, walang charge inside, 0 lang to. And then I'm left with this problem. Okay? I just have to integrate this again. 1 over 4 pi epsilon naught Q. And then lalabas ay negative 1 over R prime evaluated from infinity to R. And this gives me Q over 4 pi epsilon naught. Tapos, nagka-cancel na yung negative sign. So, this is 1 over capital R. Okay? Tapos, pag in-evaluate natin sa infinity, 0 lang din siya. So, wala nang ambag yun. And makapansin natin na yung inside, this is V of R. Again, this is your variable R, but you can't see the R, small r here. So, this means that V constant inside. Okay? So, whenever you have a electric field na 0 inside, hindi mo sure kung yung potential inside is 0. Okay? It can be a constant. Kasi, again, di ba? E can be written as negative gradient of V. Okay? So, parang derivative lang to. If V 0, then E 0. If V some other constant, E is still 0. So be careful. Tama? Be careful. So that's it. Extend ako naman. Sorry. Okay, any other questions, guys? Nalabuan? Wala nang tanong. Sir, arbitrary lang po ba talaga infinite? Okay, so sir, arbitrary lang po ba talaga yung infinity na reference point? Kahit anong value po pwede? Yes, kahit anong value. Paano po kapag 0? Ganun din makukuha. Okay, sa problem natin, pwede mong maggamitin yung 0. Mag-infinity minus infinity ka doon. In the end lang, you can say na pwedeng gawin niya. Pero minsan may mga arbitrary reference point na mas madaling gamitin. Tulad nung sa ginamit natin kanina, na infinite. Kasi 1 over r, pag nilagay mo yung infinite doon, 0 out siya. Okay? Pero kapag ginawa mo 0 yun, mahihirapan kasi magiging infinite yun. But in the end, magma-minus yun. Hindi mo lang kasi sure ngayon kung infinite minus infinite is 0. So, that ma-hassle ka in that way. Okay? So, anyway, any other problems? Kung wala na, yung problem set is due, ganun ulit next meeting bago mag-start yung class. So, i-upload ko tonight yung problem, yung solution set. Tingnan nyo kung paano ginagawa, kung paano ko ginagawa. Okay? Okay, so sorry for extending 2 minutes. So anything else? Any questions? Kung wala na, you can leave. Thank you for attending the class. Yeah. Anything. Okay. Bye. Yung 158, gawin nyo. Wala tayong class bukas.
Thank you, sir.
Bye.
Thank you, sir.